Hello, and welcome to the TI Precision Lab video on digital relative humidity sensing. In this video, we'll go over some of the extreme conditions humidity sensors can be exposed to, how it can affect the sensor output, and solutions to resolve or prevent these situations. With respect to humidity sensors, extreme conditions can include the system environment, accumulated debris over time, or chemical exposure. Extreme conditions refer to the environment that the sensor lives in. For example, a very common recommended operating range for polymer-based humidity sensors is 20% relative humidity to 80% relative humidity from 0 to 60 degrees Celsius. This means the combination of humidity and temperature that go above 80% relative humidity at 60 degrees Celsius or below 20% relative humidity at 0 degrees Celsius would create an environment that is considered to be an extreme condition. For the most part, normal environments where people live don't reach these conditions, but these combinations of relative humidity and temperature can be reached in tropical climates and mountainous ranges. However, the most common place to encounter these conditions is during evaluation testing for long-term reliability, such as high temperature operating life testing and highly accelerated temperature and humidity stress testing. In these situations, the entire system or subsystem is pushed to harsher conditions as a way to evaluate how they would perform 5 to 10 years down the road. Another extreme condition is debris building up on the sensor. For a relative humidity sensor with an open cavity, the buildup of debris can lead to inaccurate calculations over time because the debris prevents the sensor from absorbing and releasing moisture properly. This condition is driven by the environment of the humidity sensor. A real-world example is a particulate matter 2.5 sensor. These devices use relative humidity measurements as a part of calculating and determining air quality, and because of their use case, there will be debris that potentially passes over the sensor's open cavity. To correct this use case issue, it's important to think about if you need sensor protection during the assembly process or while the sensor is operating. Packages with Kapton tape cover are used when the assembly site of the boards the humidity sensor will be on have a high chance of being dusty, or if the boards need to be conformally coated while the humidity sensor is populated to protect other devices from water damage. Another option is a permanent filter if the device will be in a dusty environment during its normal operation of providing relative humidity and temperature data to the MCU. Chemical exposure in the context of polymer-based relative humidity sensors implies an exposure of the sensor to volatile organic compounds, or better known as VOCs. In normal operation, the porous polymer absorbs gaseous water molecules, which naturally have high dielectric constants. This results in an increase in the dielectric constant and thus measured capacitance of the polymer and water molecule combination. If or when there is chemical exposure, the surface layer of the polymer is disrupted through burning, oxidation, or hydrolysis, and the porosity decreases. This disruption contributes to a decrease in surface area available for water vapor absorption, making the sensor's resulting capacitance less linear with humidity and results in a gain or offset error. High-dose exposure testing has been done in this area, and the graph on the left shows the humidity sensor output prior to chemical exposure, while the one on the right represents the impact of various VOCs. Baking the units that were exposed for the most part brings the units back to almost normal, with acetone, ethanol, ethyl plus methyl, and methanol being the chemicals that cannot be completely baked out of the polymer and still affects the measurement results, as shown in the graph on the right, compared to the unexposed units in the graph on the left. For help with understanding the complete process of sensor recovery due to chemical exposure, our Silicon User's Guide goes into deeper details. It also covers different means of prevention to ensure device reliability, whether it's by use of a tape cover or permanent filter method we mentioned earlier. In other applications where the sensor will be exposed during assembly and operation, be very careful to follow our recommendations also found in this document. Additionally, to find answers to commonly asked questions, we have humidity sensor FAQs on our E2E sensor forum. Thank you for watching this video on the extreme conditions of humidity sensing, and be sure to download this presentation for direct links to the resources mentioned. We also have other resources and product information at ti.com/humidity.